If you're able to watch this video right now, that means your visual system is operating at some capacity, an amazing thing that should not be taken for granted. Your visual system is built by the immensely complex interconnections between your eyes and your brain. Unfortunately, not all visual systems are built the same. True blindness is often discussed in modern culture. However, color blindness does not get the same type of attention. Imagine if this beautiful flowing creek looked like this. This is how it would appear for someone with trit anomaly, a form of blue-yellow color blindness. Or say you stumble upon the animal of a lifetime. But this was all you could see because you had deuteranopia, a form of red-green color blindness. Or, finally, you're watching a sunset. With monochromacy, the rarest form of color blindness, there might be no incentive to do so. To understand this inequity in sight, a deeper dive into the neurovisual system is needed. While there will likely be infinitely many questions about the human brain until the end of our era, scientists have a pretty good understanding of how the eyes work in tandem with the brain. Essentially, light is reflected off of the objects in your field of view, and the different wavelengths that are reflected will cause different stimulation after they pass through the lens and hit the retina. The stimulation I am referring to is the release of neurotransmitters through the optic nerve. Feel free to pause the video and research about any one of these components of the visual system shown on the screen. They're all crucial to the operation of your neurovisual system. Your optic nerve, which consists of over 1 million nerve fibers, will travel to the visual cortex, beginning at the occipital cortex, where information begins to be processed and travels through the dorsal and ventral pathways, which are the what pathway and the where pathway, respectively. The dorsal or what pathway contains the information necessary for object recognition, while the ventral or where pathway determines your spatial awareness for the objects around you. The cause of color blindness does not occur in these complex pathways. Rather, it starts at the retina. The back of your retina consists of your photoreceptors, rods and cones. Rods are responsible for determining how much light there is in any given situation, and cones are responsible for the color. There are 3 different types of cones: red sensing, blue sensing, and green sensing. When these 3 categories of cones are all operating at perfect efficiency and working in tandem, they are able to release a soup of neurotransmitters that can display in your brain any color imaginable. Color blindness occurs when one or more of these cones are not functioning or not functioning properly as evolution intended. Displayed now are the cone's sensitivities to different wavelengths of light. For example, the protanope does not have a red sensing cone that is active at all. And for deuteranomaly, the green and red cones are sensitive to very similar wavelengths of light, causing confusion between red and green colors for people with this condition. Color blindness is almost always caused by genetic mutations that are passed down from parent to offspring. While this animation is not accurate at all for how genetic mutations work, I did find it quite visually appealing. Countless research has shown that color blindness is far more prevalent in men than women, and while the figures cannot be exactly accurate, it is by a significant margin. This is an unfortunate statistic for us guys. Everyone knows we have enough advantages as it is. It is truly underestimated by the normally sighted person how important color is to view our world and to learn. Color coding is a widely implemented and effective system used in schooling. However, there is no alternative for the colorblind person. While color blindness can account for many learning deficiencies in children, it can also have a huge effect on behavioral differences as well. A color-coded blackboard such as this may be easy for the normally sighted person to understand. Imagine how much more difficult it would be to read if it looked like this. For the behavioral side of this issue, a great example is children who are picky eaters. This plate of vegetables surely looks much less appetizing now, doesn't it? The boundaries and problems that being colorblind causes does not stop when you become an adult. Rather, they just become more serious. Imagine trying to read this national forest map when it looks like this. Or trying to buy a bouquet of flowers for your better half, not knowing what they will see when you bring it home. A very important study for understanding colorblindness was published in BMC Ophthalmol in 2017 and surveyed colorblind people to see how their condition affects their daily life. Participants were surveyed about the topics displayed on the screen. Here are the results from the survey, averaged and categorized. For our purposes, the most important rows to pay attention to are emotion, health, work, positive mindset, and SF36MH, which is a test to determine mental health. Pay attention to the different values between CB, which stands for colorblind, and normal in these different rows. Responses were averaged on a scale from 1 to 6, 1 indicating that this area is a severe problem for the individual, and 6 indicating it is not a problem whatsoever. While there are a few instances where the value is the same for both colorblind and normal people, in every single other example, the normally sighted person is more fit to live in our society and mentally healthier as well. While these are very unfortunate statistics, they are reality and they cannot be avoided. On a more personal note, after completing this research about colorblindness and its effects on daily life, I wanted to see how one of my favorite activities, cycling, would appear if I were colorblind. These sequences were shot on the North Bank Trail in the great city of Richmond, Virginia, where I attend university. So just relax and observe the differences between how I see it and how a colorblind person would. I am hypothesizing that seeing in this manner would not stop me from doing the things I love, I can clearly see how it would have an effect on my mental health. This is simply not how humans evolved to see. If you are normally sighted like me, please never take that fact for granted and be a little more considerate to the people who aren't. And thanks for watching.